Hello students, welcome to Organic Chemistry session. This is Dr. Suresh Babu here. Today I'll be discussing on Aldol reaction. So most of you know this is most important and most beautiful reaction, especially for the PU board and also IIT level and also NEET level. So I'll try to give simplest or easiest method to predict the reaction. I'll try to give simple trick. Okay, so how exactly the product formation is occurs from the reactants. So what is Aldol reaction basically? So basically Aldol reaction is aldehydes or ketones containing alpha hydrogen undergo self aldol condensation with diluted sodium hydroxide or potassium hydroxide or barium hydroxide or sodium carbonate or potassium carbonate to give the beta hydroxyaldehyde. The basic thing that we have to remember, aldehydes or ketones must contain alpha hydrogen. In the presence of the basic medium, mild base generally we'll use. In the presence of mild base at high temperature, we will end up with alpha comma beta unsaturated aldehydes or ketones. So what is aldol? What is aldol? Here ald means aldehyde. Ald means aldehyde. Ol means alcohol. So here you may ask one question, sir, you have written alpha comma beta unsaturated aldehydes and ketones, but where is alcohol is coming? If I don't use high temperature, the intermediate compound that we are going to get here is beta hydroxy aldehyde or ketone. Again, you may ask one question, sir, why this is called to be aldol? Why not, ketol? Okay, ketol reaction. So basically, aldol reaction is applicable to any type of aldehyde containing alpha hydrogen. So, for example, if I take CH3, C double bond OH, here we are going to take 2 moles, and in the presence of basic medium and water and high temperature, okay, or else instead of temperature I'll just use water only, you will end up with here CH3, CHOH and CH2, C double bond H. So the equilibrium that is formed between the reactant, that is aldehyde, and beta hydroxyaldehyde, the most favorable shift that is taking place towards the product side. But whereas in the case of ketones, for example, if I take ketone containing alpha hydrogen, for a best example is acetone. In this case, if I use now, the same condition, OH minus water, that is the basic medium followed by water. So here also you are going to get beta hydroxy ketone, but the favorable condition trying to shift the equilibrium towards to the left side. So successfully it will works for aldehyde, not for the ketones. I'm not saying the beta hydroxyaldehydes will not be formed, but that is wrong. It will be formed, but that is in the product ratio is very less. So here that I'm going to write for this directly, okay. So this is the direct product I'm going to write for this, CH3C double bond O, CH2 and COH and CH3 and CH3. So initially what we are getting here is this is an alpha, this is an beta. Alpha beta hydroxyaldehyde in this first one. So here again you can see this is now, this is alpha position, this is beta position, you will get beta hydroxy ketone. So that is why this is called aldol reaction, not ketol reaction. Okay. So aldol reaction is very successful for the most of the aldehydes containing alpha hydrogen, but not respect to the ketone. All aldehydes, all ketones will not give very good yield. Yield wise, the product ratio with respect to reactant is less. Okay, so that is the reason this reaction is called to be aldol reaction. Okay, so ald means aldehyde, ol means alcohol. So what exactly will happen? There are two types of reactions we are going to see. The one is self-aldol reaction. Don't worry, I'll be giving shortcut methods also. Self-aldol reaction. The other one I'm going to talk about crossed aldol reaction. Crossed aldol reaction. So what is the major difference between these two? Okay, self-aldol reaction means we use in only same type of aldehydes or ketones. In cross-aldol reaction, the aldehydes and ketones must containing hydrogen, but we are going to take different here. Different aldehydes or ketones we are going to take. This also must containing alpha hydrogen. So self-aldol reaction, if two same molecules are involving, it may be aldehyde or it may be ketone. So if I write now 2 moles of CH3CHO, this is now called to be self-aldol reaction. So in the presence of OH minus water, you'll get beta hydroxy aldehyde, CH3CH2OH, CH2C double bond OH. Further, at very high temperature, this will undergo dehydration to give CH3CH double bond CHC double bond H. So cross-aldol reaction I'm not going to discuss right now. So this will, I'll just add one more video for that specially. Okay, because we can have various reactions to discuss about it. So what is the mechanism is involving self-aldol reaction or condensation? So here the mechanism of the reaction, the first step is very simple. What we have to do here is step 1, we have to take the aldehydes or ketones containing alpha hydrogen. So anyway, we have taken already reaction where 2 moles of acetaldehyde is involving the reaction. So you can see acetaldehyde. So for to simplify this entire reaction, we are taking as here alpha hydrogen. What is exactly will happen? This is now alpha hydrogen. We are going to take, it may be sodium hydroxide, it may be potassium hydroxide, any base. I'm going to use as a OH minus for our better understanding. Okay, so OH minus here act as a base. Now this alpha, this is alpha hydrogen. This base will abstract the proton here. This is alpha hydrogen. What you get? CH2 minus C double bond 1H. This is called carbanion as an intermediate. This is the step 1. Step 1 is involving generation of carbanion. This carbanion further again undergo a resonance with the C double bond. So you can see that this is going to involve with the C double bond. Basically what you are getting here is enolate ion. Okay, enolate ion. This is the kind of intermediate that we are going to get. What is the step 2? Step 2 is involving the either you can take carbanion or invalid form also you can take. So for our understanding, I'm going to take carbanion only, but we have to take generally invalid ion. But for our better understanding, to get the easiest way, I'm going to take carbanion. So we have one more of aldehyde, that is CH3C double bond H. In the second step, what is happening here is the nucleophilic addition. Why? The CH2 containing negative charge. This is now act as electron rich. This is now act as electron rich. Now act as a nucleophile. This will undergo nucleophilic addition with CH3C double bond H. So what will happen again? So you get CH3CO minus and bond H, CH2 C double bond O bond H. So here we are going to use water. Finally the O minus will capture this hydrogen or H plus from water to become beta hydroxy aldehyde. CH3CHOH C double bond O bond H. Finally step 3 dehydration reaction. So now you can see that this is the functional group. Functional group attached to the first carbon is alpha, next to that beta. So this is now basically beta hydroxy aldehyde. Next step is dehydration. So you can see I'm going to write the same structure, the other way. So why I'm writing, I'll just discuss this part again. So look at this, okay? For our convenient and simplest way purpose, I have used. So if you look at this molecule, there are two different hydrogens are present with respect to the OH. So we can eliminate any side in terms of water molecule, dehydration or water molecule. We can remove it, either this one or this one. Now we can see the possibility. There are two possibilities. The one possibility is you can get here. For example, I'm going to take A, this is B now. In case of B, I'm going to end up with CH2 double bond and C, and we have here CH2 and C double bond O H. Still we have hydrogen. This is now B product. If I add now A, CH3, CH double bond CH, C double bond O bond H, you get this is A. So don't get confusion. As soon as we eliminate water, you generate the new bond. Here between these two you are going to generate new bond. If you eliminate in the H and OH. Similarly, if you eliminate H and OH with respect to the CA, so here also we are going to generate double bond. Now here this is not favorable, this is favorable. That is why we are calling as alpha comma beta unsaturated carbonyl compound. What is the reason? The double bond here in the case of A, double bond is undergoing resonance with the carbonyl compound. What is carbonyl compound here is aldehyde. So you can see that double bond, single bond and pi bond. There is an alternate double bonds are present. So that is the reason. So you will end up with here the resonance product. But if you look at this B, where we have eliminated water, you have this molecule where you can see this aldehyde, this double bond is not undergoing resonance, right? So that is the reason this product formation is not favorable. This product formation is favorable. So I think all of you are looking for the tricks for the self-Aldol reaction. So how do we end up with the simple product, or how do we write product easily from the reactants? Okay, I'm going to explain this part. Hope you're understanding this properly, the mechanism. I'm going to make some simple trick to understand that. So I'll be taking here same way, CH3 C double bond OH. It's very simple. When you take two same molecule, is very easy. In one molecule, you have to take C double bond O. In one molecule, you have to take C double bond O. In another molecule, you have to take two hydrogens. In another molecule, you have to take C. These two are same only, right? This is acetaldehyde. This is also acetaldehyde. That's what we discussed just now mechanism. So how do you get product directly? So we can remove directly here as a water molecule. Whatever the double bond is there, this double bond directly will connect with this carbon. So finally we are going to get CH3, CH, double bond, CH and C double bond OH. It's very simple, right? So, but if you want to get beta hydroxy aldehydes or ketones, so you can go through the mechanism method, okay? Or else if you still want to have that product also, my suggestion, wherever this is alpha, right, this is beta, right? So if you want to get beta hydroxy aldehyde also, what my suggestion is, wherever the beta carbon is present, no, you just remove that double bond, make here directly, add here OH directly. I'm going to add OH directly here, and I'm going to add one H on the carbon atom. So finally what you are getting, this is what you are going to get as an intermediate. Okay, so this is the intermediate you will get. This is how the reaction generally will move towards to the this process, correct? So if you want to get this, so you need to break this pi bond, beta position add OH, alpha position add hydrogen, that's all. So you will end up with here beta hydroxy. So this is I can say that this is a butanaldehyde. Okay, butanaldehyde. This is the simple trick. Not only that, you can take any kind of example. I'll be taking one more example here. So 2 moles of CH3, CH2, C double bond H I'm taking. Okay, so here if you look at this, this is also, there is again alpha hydrogen is present. Okay, now in the presence of again OH minus, same condition, water and heat. So how do we write? I'm going to write directly here. Now I'll explain how we are getting this product. Okay, so C double bond OH, I'll be writing here double bond, and this is CH2, and here CH3. Okay, there is a hydrogen. Then I have written directly, but how we are getting this product is very simple. So in shortcut method or trick, I'll be writing here CH3, you take now hydrogen and here hydrogen, and we have C double bond H, right? So I'll be taking the same molecule now, same molecule I'm going to take. I told you already, if you are taking here C double bond O, in another molecule you have to take 2 hydrogen, but in this molecule I'm taking 2 hydrogen, and other side I'm taking aldehyde. So I'll be taking like this, you can see that. So any side, vice versa, because both are same molecule, any side you can remove water molecule. I'm going to remove like this. So after removing water molecule, you are going to end up this product. Hope this is clear to you. So very simple, wherever you have alpha hydrogen, in one molecule you have to take 2 hydrogen, in another molecule you have to take 1 oxygen. After removing that water, you have to make one double bond between 2 carbon atoms. So this is called self-Aldol reaction. I'll be taking one more example also. So if I take now 2 moles of cyclopentanol, so how we are going to get this product? Using the same condition. Okay, same condition, OH minus water and heat, something like that. So trick again I'm going to do. So if I take now cyclopentanone, in one molecule I'll be taking 2 hydrogens as discussed. In another molecule I'm going to take ketone. You can see both are same only. Don't get confusion. This is cyclopentanone only. This is also cyclopentanone. Okay, don't get confusion. So I'll be removing water molecule minus water, and I'll be getting directly C double bond O, and here double bond, and I'm going to make something like this. Okay, so this is now again alpha comma beta unsaturated carbonyl compound. So if you're understanding properly what is sulfur-aldol reaction, and I will be giving some examples to you, please do this. Okay, please do this and write it in the comment box. So OH minus, water, heat, what is the expected compound? Okay, so we'll be taking 2 moles. See, in the examination they will not give any in the mole ratio, like how many molecules of you are taking. Whenever they give aldehydes containing alpha hydrogen, you should assume that there will be 2 molecules of the aldehyde or ketone. Okay, thanks for watching. We'll meet in the one more session. Thank you.